So we looked at our 6 mountains again. So we got Mount Everest, Mount Mitchell, Mount Araki, Mount Aconcagua, Hitaka, and Naranaya. And we discussed what we found out. So we know Mount Everest, Mount Araki, Mount Aconcagua, and Hitaka are all still increasing in height. Naranaya is not increasing, nor is it decreasing. And Mount Mitchell is decreasing. So we know that plates hitting together make mountains. So we're still trying to find what happens with Mount Mitchell and Mount Naranaya. So that's what we're going to look at today. We looked at our cards again, and when I just looked at these really quick, we can see that they have marine fossils, both sedimentary and volcanic rocks. This says they're very old, even taller than the Himalayas at one point. And for Mount Naranaya, also the same thing, so sedimentary rock, volcanic rock, marine fossils, much older than the Himalaya mountains, and about the same age as the Appalachians. Okay, so we've got that information on these. We look at a map of where some plate boundaries are and looking for patterns. So we see Mount Everest, Mount Hitaka, Mount Cook or Araka, and Mount Aconcagua are all near plate boundaries. So I see that kind of in common. And then when we look at Mount Naranaya and Mount Mitchell, we see that there are no plate boundaries nearby, which kind of explains why they're not growing. They're not being pushed together, so it's not going up. But that still asks a question, because if there's no plate boundaries there, then we have to ask, why are the mountains there in the first place? Because if there are no plate boundaries, then they never hit together, and because they never hit together, nothing ever got pushed together to make it higher. So that's what we've got to explain today. But we also talked about that this is just a snapshot in history. This is what the Earth looks like today. And as you saw in the previous lesson, that Pangaea was around, and Pangaea did not look like this. So we know that the Earth is changing. So maybe something in the past happened where some mountains got formed. So let's take a look. We have another simulation. So here's a simulation. It's going to show us the Earth. So I'm just going to show you, we got the Mid-Atlantic Ridge here. We've got South America, North America. It's going to go around once just so you can kind of see what the pieces are. This is now. So up here it says how many years ago. So this is 0 years ago, so this is now. Here's the Pacific Ocean. There's the Rockies. There's Mount Aconcagua down here. Mount Mitchell's going to be someplace right around there. Pacific Ocean. Here comes Australia around the corner. So there's Australia right here in the left, bottom left. Asia's coming up on the upper left as it keeps rotating here. This is the western side of the Pacific Ocean here. Here is the Himalayas in white because they're so high. There's India coming up. So here's India. There's the Himalayas. And here is part of Africa. Here's the Indian Ocean down in here. Coming up on the Middle East. So Egypt is here, as you studied in social studies. Here's Africa, and then Europe at the top. And coming back to the Atlantic Ocean with the Mid-Atlantic Ridge. So we've kind of gone around once. What I'm going to do is I'm going to try to find Mount Mitchell, which is near Asheville, North Carolina. So what this is going to do, it's going to put a little pinpoint so we can see where it is. So if anytime you see the red dot right now, that's where Mount Mitchell is. So now we're going to go back in history and see what happened to Mount Mitchell. So we went back 20 million years. Still a little bit of mountains there, nothing much. Same thing. Back 50 million years ago, you can see that some of the United States was actually covered with water. Still a little bit of mountain there. Now remember, we're going back in history here. Here is 90 million years ago. We got water going right through the United States, right up the middle. Florida's, Texas are all underwater. 105 million years. Mount Mitchell is still somewhat of a mountain. You can also see that Africa, South America, and everything are getting closer together. There's South America and Africa are almost touching. North America is getting closer to Europe. Looks like Africa has finally hit South America there. Still some mountains in Mount Mitchell. North America is getting close to Africa and South America. Look at that. Florida is almost part of South America. The East Coast is almost part of Africa. Oh, here we go. Look at this. The Atlantic Ocean is gone. Looks like a river. So 200 million years ago. Looks like the mountains were a little bit taller. Longer too. It's like a one stretch. Okay, so here is a place where we've got one big landmass. That's Africa, or sorry, South America here. Africa and North America are all part of one thing. But the mountains are here. And we remember we went back in history. So things didn't hit. So everything kind of came together, but remember this is in the past. So if we go forward in the future, this is what happens. It's actually separating. So this is coming towards us now in time. So things are being pulled apart, divergent plates. So this is being pulled apart. Those mountains are already there when we went back to 240 million years ago. So let me go back. So back to 240. Okay, so 240 million years ago, those mountains are already there. And they're only pulling apart. So that's not going to make a mountain. That's going to do something else. So let's go back even further. Okay, so there's mountains there. So something happened before this. Wow. Those are glaciers on top of mountains. Glaciers on top of mountains. So this must be when it was like taller than Mount Everest. Mountains. 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 This is interesting. So here's Mount Mitchell underwater. So it wasn't even a mountain yet. So now we can start going forward. So let's go forward from here and let's see what happened. Okay, so here is the place that will be Mount Mitchell in the water, and here's a piece of land. We now see that that piece of land got pushed into land. So ocean floor got pushed into land. Remember, we have ocean floor hitting land will make the continent go up. So let's see if that happens here. Yep, so we have one plate ramming into another, making it higher and higher. So this North American plate kind of slammed into another plate here. Make it even taller, taller, right there. So that's the highest. At 280 million years ago, that's when Mount Mitchell was as high as Mount Everest with glaciers on top. And in 20 million years after that, it's already going down. So two plates had hit at one point about 380 million years ago to make Mount Mitchell. And then since then it's been pulling away and getting smaller and smaller. We don't know why it's getting smaller yet, but as we come to the future and the present, you can see that it just keeps getting smaller and smaller. So that shows us Mount Mitchell. Let's see if the same thing's going on with Mount Narodnaya. So here's a town in Russia where Mount Narodnaya is close to. And we'll start here again. So we'll do the same thing, we'll go backwards. So there's Mount Narodnaya, all green, kind of just a little bit of a mountain there, some brown, that's about it. 35 million years ago, looking the same. Getting close to water. Back on land, close to water. Back on land. Back on land, no mountains. Just a little bit of a raised area there. Still the same. Still the same, not a lot of mountains there. Not a lot of mountains. Not a lot of mountains where Mount Narodnaya is going to be. Back to water. Oh, here are some mountains. So something happened here. Let's take a look. Back in the water. Okay, so here we are. It's a low spot in the water. Also, because they're in water, remember these places have marine fossils. That's kind of interesting. So let's see what happens here. So that looks like it's going toward a piece of land. So the same thing happened. Ocean floor rammed into a piece of land, pushing it up. And then again, right about that same time, from the 280 to 260, it goes from very high to pretty much nothing. And as we come back to the present, We see that it just never gets hit again to make any more mountains, so it's actually just a remnant of that collision long time ago. As we come to the present, here we are, and that's what we have. So a lot of these mountains are not because of recent things, they're because of very ancient collisions, before Pangea even. And we can take a look at one more. So we'll take a look at Mount Everest. Here's Mount Everest, there's the Himalayas. So we'll go back. So big mountain range there. Still mountain range. Oh, and we see India moving off of Asia, going back into the Indian Ocean, closer to Africa. So it looks like India came from Africa and then started moving northeast. This is going in the future now. So going towards Asia, still in the middle of the ocean, hits Asia and forms our mountains. Okay, so that's what happened with Himalayas. India actually rammed into Asia and created the mountain range. So now we got a little more information about what's going on. So sometimes it's not the recent past that makes the mountains, it's a very ancient past, hundreds of million years ago. So that's what we're looking at today, is those three mountains, or two mountains, Mount Narayana and Mount Mitchell, that were not growing, but now we understand what was happening there. There's no plate action going on, but in the past there had been.